Ahead and look at some, well, we're going to develop a tool to determine if we have a right triangle or not, because sometimes we're looking at triangles and they look like they're right triangles, but if we're not given the information, then we had no way to determine. Now we're going to have the tool. So we're going to go ahead and look at this inequalities. So if you know that your c square, so the longest side will be your c, if I square that and I add the other two sides and it's less than, then you're going to have an acute triangle. If I square the c and then I square the other two sides of the triangle and I add it and it's greater than, then you have an obtuse triangle. So now we're able to determine if we have right triangles or not when our triangles they don't give us information if we have a right angle or not. So let's go ahead and look at this triangle here. So on number one, it looks like it's a right triangle, right? So now we're going to go ahead and use this theorem that we learned about to determine if it is a right triangle or not. So the first thing is to identify which side is your c, because depending on what c square is in comparison to the sum of the other two sides, then we're going to know if it's right, acute, or obtuse. So if I take the square root of 365, that's 19.10. What that means is that that side will be your C because it's the longest side. The other two sides will be your A and your B, and it doesn't matter which one you make your A or your B. So let's go ahead and write what this equation slash inequality could look like. Take the longest side, square it. I'm going to write question mark because I don't know if it's going to be equal to the sum, if it's going to be less than, or if it's going to be greater than. We take the other two sides and we square them and take their sum. Anytime you square a radical or anytime you square a square root, it cancels out the radical. So if I square 365, that's just 365. If I square the square root of 365, that's just 365. Square 13, we get that. And now I just have to do that sum and I get 338. So now we can see that our C, which was the longest side square, is going to be greater than the sum of the other two sides square. So if we have that situation, we know that it's not going to be a right triangle or else it would be equal. So that means it would have to either be an obtuse or a acute triangle. So if C is greater than, the C square is greater than, then we're going to have an obtuse triangle. All right, again, we're going to repeat the strategy here. This looks like a right triangle. We're going to determine if it is or not. First thing is identifying which side is the longest. And we have radicals involved, like that side that I highlighted. We're going to go ahead and approximate it with the decimal so that it's easier to compare it to the other sides. So square root of 41 is 6.42. If I multiply by the number outside of the radical, then I would get that that side is approximately 12.8. Right? If I compare it to the other lanes of the triangle, then that would be your C because it's the longest side. And once again, it doesn't matter which size you assign as your A or your B. And we're going to go ahead and set up our equation or inequality. Again, question mark because we don't know if it's going to be greater than, less than, or equal to. Squaring 8 gives us that. Squaring 10 gives us that. And if I square 2 radical 41, I'm going to go ahead and show the work on the side. So the squaring, if I square the outside of the radical, that's just 2 squared. That gives us 4. And if I square radical 41, that just cancels the radical. So we end up with the radicand, which is the number inside of the radical. Those two were together initially, so that means we're going to multiply those two results. And that gives us 164. So when I squared RC, it gave me 164. And then we do the sum of the right side here. That gives us 164. Since we get that it's equal to, that means that we do have a right triangle. This satisfies the Pythagorean theorem. All right, let's look at this triangle here. We have two sides that involve some radicals, so I'm going to approximate what their lengths are in decimal form. Square root of 42 is approximately that there. The other one, I take the square root of 13, and then I'm going to multiply it by 4. Which will be approximately that there. So that means that our longest side is the side that has a length of 15. So that would be your C. We'll set up our inequality here. All right, square 15 squared, that's 225. Question mark, we don't know if it's going to be greater than, equal to, or less than. Squaring a radical cancels the radical, so we just get 22. And for the second one, we repeated the process. Take the sum, we get that, compare it to our c squared, which will be less than. And if your c squared is less than, then you have an acute triangle.